Okay, so this is chapter 13, Essential Macroeconomic Tools. Um, this is similar to chapter 4, where we essentially covered a lot of the basic stuff that you may have learned in other class. This lecture should essentially set you up for the macroeconomic analysis we will do going forward. So I'm going to be using OneNote for this, and I'll try and uh, take as many notes as possible. So let's see, chapter 13, it's essential macroeconomic tools. So let's start with section 13.1. 13.1, make this a little bit thicker. And this is a refresher on the closed economy. Okay, so essentially, if you remember from your macroeconomic classes in the past, um, um, the output for an economy is measured as y equals c plus I plus g, where c is consumption. Let me erase this real quick. C is consumption, I is investment, and G is government spending. If you have noticed, imports and exports are missing because, as the section header states, this is a closed economy. So, of course, there's no imports and exports. Okay, so let's start with the basic analysis. Maybe we could start by drawing a graph representing an economy. So here's a straight line. Here is the x-axis. And what we have is y-axis has interest rates and x-axis has output. Now, if we were to draw an IS curve, what we see here, the downward sloping IS curve tells us the lower the interest rate, the higher is the output, and of course, the higher the interest rate, the lower is the output. So let's start with a low interest rate. And we see what happens when interest rate is I1, the output is Y1, and we'll call this point A1. And of course, if the interest rates rise, the output decreases from Y1 to Y2. Once again, this is super basic. This is something that you must have done in your macro class if you have taken it in your prior semesters. Okay, so this is the simple IS curve diagram. And as you can see, as interest rates rise, output declines, as shown by the movement up the curve from A1 to A2. Well, some of the basic things to keep in mind about the economy and the IS curve is that consumers spend more when they earn more. Therefore, consumption is a function of output, right? So we could say consumption is a function of output. Another thing we could say is consumers also spend more when interest rates, right? When interest rates are low. So what does that mean? For example, if interest rates are low, you're more likely to buy a new car with a car note that's smaller than if interest rates were high, or you may be able to buy other electronic devices that are relatively more expensive on a lease or by borrowing money because interest rates are lower. So then we could say interest rate is a function also, or consumption is also a function of interest rate. So put together, we could say consumption is a function of interest rate and output. Okay, consumption is a function of interest rate and output. On the other hand, let's look at the second piece of the output function. Firms invest less when interest rate is higher or is high, and vice versa. So here we could say, therefore, investment is a function of interest rate. Now, could we then say investment is also a function of output? Not necessarily. Firms, the only thing they care about is, at least from an economic perspective, or at least from this course's perspective, the only thing they care about is interest rates, because interest rate is a cost to them. So the lower the interest rate, the more they're willing to invest. The higher the interest rate, the less they're willing to invest. They don't care about the output, economic output. In fact, if anything, investments results in economic outputs, not the other way around. So that's something that we should keep in mind. So we spoke about investments, we spoke about consumption. What about government spending? Government spending for economic models is assumed to be independent um, of interest rates um, or output. Why? Because government is essentially a monopolist when it comes to printing money. So it has the sole ability to print as much money as it wants and spend as much money as it wants. So government government spending is essentially independent of pretty much everything. We think in economics we call it exogenous. We assume it to be independent. Um, as far as the chart goes, is it possible now for you to be not in an IS curve? So let's think about a point. Let's draw a point that's not on the IS curve. So we'll call this point A3. So what is happening here is the market at A3 is in disequilibrium. Why is it at disequilibrium? Well, one, of course, obviously, because it's not on the IS curve. But more importantly, what's important to keep in mind is firms who are producing the output of Y1 at point A3 are paying more in interest at I2 than they could if they were at point A1. So if they were at point A1, they would essentially pay a lower output, a lower interest of I1. And as we discussed a few minutes earlier, pretty much the only decision a firm has to make to make a determination about its investment options is the cost to borrow money. And so we're at a disequilibrium here because at A3 firms are paying way too high of an interest rate for the output that they are achieving. Okay. So the only way to respond in A3, if you're at A3, is you would essentially have to cut production because your interest rates are too high, and you essentially move in this direction. And you'd end up at point A2, where now you're back at equilibrium at that interest rate, and the output is Y2 and not Y1. Okay, so that is a primer on section 13.1. Let's do section 13.2. I'm going to scroll up a little bit. So section 13.1.2, this is the financial markets and the role of monetary policy. Okay, so I'm going to scroll all the way up. Okay, so before we start discussing the role of financial markets and monetary policy, let's start with some assumptions. Let's assume that all loans are riskless and identical. Why do we assume this? Because this is the only because only with this assumption can then we assume um, that there's only one interest rate that applies to all loans. In other words, in the entire market of borrowing money, only one interest rate applies to all loans. And of course, we know from real life experience that that's not necessarily the case. There are multiple interest rates. For example, your credit card interest rates is way higher than your mortgage interest rate because mortgage is secured by your home and credit card is an unsecured line. So of course, higher risk, therefore higher interest rates, right? So assume that all loans are riskless and identical. Therefore, there is only one interest rate that applies to all loans. And of course, suppliers of loanable funds are willing to supply and demanders of loanable funds are willing to demand or borrow at this rate. Okay. So having said that, of course, uh, there's an inverse relationship between interest rates and the willingness to borrow, right? So as interest rate goes up, as interest rate increases, lenders, of course, are more willing to lend. But on the other hand, borrowers are less willing to borrow. Okay. So these are some basic sort of characteristics of the financial markets and the role of monetary policy. Now the question is, outside of interest rates, are there any other determinants of supply and demand of loanable funds? So supply and demand of loanable funds. Sure. So number one is wealth. Why is it a determinant? Well, first of all, is that a determinant of supply or demand for loanable funds? Well, it's a determinant for supply of loanable funds. Why? Because wealthier people tend to save more. And savings are essentially the supply for loanable funds. Optimism. If households and firms are both optimistic of their ability to repay the loan back, they'll borrow more. Of course, it works the other way around as well, where financial markets are more willing to borrow if they lend, if they think that the chances of them getting the money back is higher in the future. So if they're optimistic about the future, then of course it works both ways. So government borrowing, right? This is an interesting piece. Government borrowing actually decreases the supply for loanable funds because think about loanable funds as a big pot of money, right? And anybody and everybody can borrow from that pot of money. The problem is when governments borrow too much from that pot of money, very little is left for investors to borrow from that money. So government borrowing is actually a deterrent to the supply of loanable funds. Okay, so the larger the government borrowing, the lesser the money available for firms and consumers or individuals. Okay, so government borrowing is one. Central banks play a very important role in determining how much loanable funds to make available for the markets. And what are their decisions based on? Well, most central banks have what's called a dual mandate, is to achieve a maximum level of employment with um, stable price levels. And so they're constantly changing interest rates to make that happen, to achieve the highest level of employment um, and maintain constant price levels. Okay, so central, and they do so by buying and selling bonds and other securities, which in turn then um, makes determines the exchange rate or the interest rate. Okay, so the ability of central banks to create money gives them monopolistic control over inflation and interest rate. Okay, so those are the determinants of supply and demand for loanable funds. Okay, let's move on to section 13.1.3. And in this section, we introduced the general equilibrium. So general equilibrium takes some parts from things we have talked about um, in the previous graph and adds to it. Okay. So this is just an example of how general equilibrium works. Okay. So in 2008, Lehman Brothers collapsed. So households became worried and began saving and cutting down on consumption. As a result, firms began cutting back on employment. Right? And let me draw a graph here real quick to show you this impact. So let's say this was the original IS curve. Let me do that again. And this was the monetary policy curve. So we'll call this MP, and this is IS. At equilibrium, what we have is we start out by point A. This is before the financial crisis. And here's the output. This is the interest rate. And we're at this point before the financial crisis hit. And so once the financial crisis hit and the firms began cutting employment because people stopped buying things, the IS curve shifted to the left. We'll call it IS prime. So the IS curve shifted to the left to IS prime, and as a result, output decreased, and now we're at point B. So the interest rate remains unchanged, the output decreased, and you're at point B. So the only thing that can happen from here on, well, let me do this. The only thing that can happen from here on is because central banks control interest rate and therefore the monetary policy, they responded by lowering interest rates. So let's do that. If you lower the interest rate to I prime, what you do is you're also walking down the new IS curve. Call Y, and this is point Y prime. You end up at Y double prime. Okay, so you end up at Y double prime. So what has happened is, if you look at the graph, first output shrank, therefore it created unemployment. Federal Reserve or the central bank responded by lowering interest rate, and yes, the output is back. Output is higher, although it's not back at its level before the financial crisis. But that's the whole point of a central bank, is to cushion the blow from a crisis like the financial crisis. Okay, so the central bank responded to increased unemployment by lowering interest rate from I to I prime, causing the output to increase from Y prime to Y double prime. Once again, this is super basic. This is something that you should have done in any macroeconomic class you've taken in the past. So section 13.2, the open economy. So I know we are covering a lot of topics, but it's important to state here that, once again, this is just a refresher class. Chapter 13 is just providing a refresher, and we're going to dig a lot deeper into each of these topics as we move along in the semester, and look at these topics from a European Union and integration perspective. Okay, so for now, I know I'm just pretty much starting all these topics and not taking it anywhere, but eventually we'll go somewhere with these topics. So remember when I started this lecture, we talked about how output for a closed economy was y plus was output y was equal to c plus I plus g. Well, now we get to change that and add exports and imports. So exports are what you're buying in, and imports are what you're selling, right? So output is made up of essentially where x minus m, x minus m equals net imports or net exports. Okay. So once again, we already addressed consumption, investment, and government spending, and we said C is a function of, so we could do this, it's a function of interest rate and output. That still holds true. Investments, we said, is a function of um, interest rate. We said G was exogenous. How about X and M? Let's think of what happens with X and M. So an increase in interest rate, um, of course, decreases local consumption. And by local, let me rephrase that and say domestic. Okay, so an increase in I, of course, decreases domestic consumption, as I explained before, but higher interest rate entices foreign investments, right? Because foreigners now want to earn higher interest rate. So foreigners invest by first converting their currency into home country's currency. In doing so, home's currency appreciates and foreign currency depreciates. Cheaper foreign currency increases home demand for imports, right? Of course, because if the foreign currency is cheaper, that implies that foreign goods are going to be cheaper as well. So you're going to demand more imports. And of course, just as importantly, if home currency becomes more expensive, foreigners are going to demand less of home products. So, and foreigners demand less of homes exports. This should make very common sense to you. The big takeaway is that goods and services market goods and services market become interdependent across countries. And change in foreign spending will affect demand for home goods through lowered exports. Okay. Let's move on to section 13.2.2. Financial markets. Within that, we'll talk about interest rate parity condition. So what is the interest rate parity condition? Basically, interest rate parity condition says the interest rate prevailing in any two countries is pretty much identical because the exchange rates between those two countries will change such that you earn the same returns no matter where you invest. And I know this can be a little bit confusing, so let's think about it from an example's perspective or with an example, right? So imagine you're a trader. Imagine you're a trader um, that works for a large bank, and you have, of course, your job is to maximize returns. You have two options. Option one is to invest let's say $100, invest $100 for IH at home. So you can invest $100 at home for an interest rate of IH. Or option two is okay, this is a multi-step option. Convert $100 into euro, invest those euros in the EU at EU's interest rate, we'll call it IF, F as in foreign, for the same period of time, right? For the same period of time as option one. And then at t plus one, which is in the future, convert euros back into dollars. Okay, convert euros back into dollars and see what you have. So that that would be your return, right? If you have more than $100, you made some money. If you have less than $100, you lost some money. And this applies to both options. Okay, and so the idea is, of course, if exchange rate is fixed, this becomes an easy decision because all you're doing then is comparing the interest rates and investing in the country that offers higher interest rate. Because all you do is compare home's interest rate with foreign's interest rate and invest in the country that offers higher interest rate. Okay? So now let's think about, of course, the more prominent, the more possible outcome is if exchange rate is floating. If exchange rate is indeed floating, then here's the problem you face. If let's say you do this step number one, so you do this, you convert $100 into euros, and then you invest those $100 in step number two, we'll call this 1, 2, 3, in European Union at IF. Well, two things could happen. As you're waiting for your money to essentially earn interest, if foreign exchange rate if foreign exchange rate appreciates relative to home, so in other words, if euros become more expensive relative to dollars, you get more home currency when you turn around and convert it back into dollars. So you'll essentially not only earn interest rate, but you'll also make some money off of the exchange rate, right? So let's jot that down. If exchange rate is floating and if exchange rate appreciates after you invest in foreign, which could in this case is EU, then you earn IF and you of course earn the foreign interest rate and you make money on the interest rate on the exchange rate differential. Exchange rate right? So that's one possibility. The second possibility, if exchange rate is floating, is if exchange rate depreciates after you invest in foreign, which once again in this case is European Union, then you earn IF just like in the case above, but you lose money on the exchange rate differential. Okay, so those are two possible outcomes if you decide to invest in a foreign country. If you decide to invest in a foreign country, okay, especially with a foreign country with a floating exchange rate. So that's what we're talking about here. So to make this decision, I mean, is there a formula that you can think of that helps you make this decision? Well, the good news is there is. To help you make this decision, there is a formula. To make this decision, we basically the two returns, right? We compare the two returns, or let me phrase it differently. We compare the returns from both options, right? Compare the returns, both options. Well, investing in home is a pretty easy calculation, right? Because all you're doing is you take the $100 and then the future value of $100 is going to be 100 multiplied by 1 plus I to the power of h, right? So that's going to be the future value. Okay, and if you want, we could do some examples. So if interest rate is 5% and you invest for 1 year, you're going to essentially say 1 plus 5%, that's going to be, you're going to end up with $105, right? Very commonsensical, very basic, right? If the interest rate is, you cross this and you say 10%, then you cross this and you end up with $110, right? Very basic, okay? The foreign piece gets a little bit tricky, right? The foreign piece gets a little bit tricky. So you start by taking that $100 you had, and remember, going back all the way on the top, step number 1 says convert $100 into euro. So you multiply that by whatever the exchange rate is today, right? So ET is the exchange rate, right? And so let's work on this example. Let's say if the exchange rate is essentially, we'll carry forward the 100, and the exchange rate is 0.9. So you essentially get 90 euros back when you exchange it for 100 US dollars, right? So you get 90 euros back when you exchange it for $100. Of course, you cross this and you say if it's 7.75, then you cross this and you get $75. So that makes sense, right? So but that was just step 1. Step 2, now whatever you get there, whatever this value is, you're going to invest it just like on the left hand side, you're going to invest it for whatever the foreign exchange rate is, right? So that's step 2. Once again, invest those euros in European Union at IF. So that's step 2. What is step? Also, let's do some math here too. So we can multiply this. We'll keep it identical. If it's 5% here and your exchange rate was 0.9, then you're going to end up with so you're going to end up with 94.5 euros, right? 94.5 euros because you get 4.5 euros in interest rate because you started out with 90 euros. In the future, you're going to end up with 94.5 euros. Okay, so that's step number 2. Step number 3 is at the end of the period, which would be t plus 1, today plus 1, which is tomorrow. At the end of the period, at t plus 1, you're going to have to convert those euros back into dollars to bring it back home, right? You're going to have to, because euros, you can't use them here, right? So you're going to have to convert the euros back into dollars and bring them back home. So the formula for this, watch how funny this gets, is the exact opposite of this. It's the exact opposite of ET. What is the exact opposite of ET? It's 1 over ET, but except it's tomorrow. So it's 1 over ET plus 1. Makes common sense, right? 1 over ET plus 1. Okay, so let's say you started out, and let me clean this up a little bit. So I'm just going to leave this at 0.9. So it makes sense to 0.9, and you end up with 90 euros, right? And then here you end up with 94 euros. Okay. So let's say you started out with 0.9, but at the end of the investment period, which is tomorrow, today plus 1 is tomorrow, the exchange rate now is 0.8, right? The exchange rate now is 0.8. So you take your $94.5 and you exchange it by 0.8 to convert it into dollars. And I'm going to use a calculator real quick for this. You end up with $118.125, right? $118. So think about what has happened. On the left-hand side, had you chosen option 1, this is left-hand side right here, so we'll call this option 1, you would have ended up with $110. On the right-hand side, this is option 2, you ended up with $118. Of course, $118 is more desirable than $110, so you would go with option with option 2, right? Here's the problem with this, okay? The decision looks, the decision is super easy because you know what the future exchange rate is. You know what ET plus 1 is, right? You know what ET plus 1 is. But what if you didn't know what ET plus 1 is? If you did not know what ET plus 1, which is exchange rate tomorrow is, and instead of 0.8, this depreciated to become from this change from instead of 0.9 when you started out, instead of becoming 0.8, it became 1.0. So in other words, you get $1 for €1. Well, guess what? You'd end up with $94.50, right? You'd end up with $94.50, which is even lesser than where you started out. Despite earning the same interest rate in both countries, at the end of 1 year or whatever tomorrow is, you end up with fewer dollars than where you started out. So the problem with making this decision is you need to know what the future exchange rate is. And of course, nobody can predict the future. But that's not the point of this problem. The point of this problem, the point of this problem is what interest rate parity condition says is that somehow these exchange rates would adjust in such a way. So the exchange rate in red right here, this exchange rate in the future will adjust in such a way where at the end of the month, you end up with $105 here at the end of the period, investment period, and you end up with $105 in the foreign country, right? That's the interest rate parity condition. Interest rate parity condition says for a given investment period, the exchange rates adjust in such a manner that you cannot earn more money in another country. So the question is, why does that happen? Why does exchange rate adjust in such a manner where you cannot make more money um, through the interest rate differential between two countries? The answer to that question is pretty simple. Walk with me here. Let's say you knew that some country was paying a ridiculous interest rate. Let's say some country was paying 10% at a time when your Bank of America account in the US is paying 1%, right? You're going to be like, you know what? I'm going to invest all that money, all my money, instead of investing it in Bank of America for 1%, I'm going to invest it in foreign country. Well, here's the problem. You're not the only person who knows that the other country is paying 10%. There are other people who also know the exact same thing. And what they're going to do is, as other people, including you, convert your dollars into that foreign country's currency, that foreign country's currency would appreciate. And then I'd be like, you know what? I'm okay with getting 9%. Even if I have to pay a higher amount for through the exchange rate, and that implies that I'm just going to earn 9%. I'm happy with 9% because at least it's better than the 1% that I get from Bank of America. And then someone else says, you know what? I'm happy with getting 8%. Once again, that's better than 1% that I get from Bank of America. So you keep going until somebody says, I'm happy to get the exact same interest rate as I get in Bank of America in the foreign country. If I get just 1 basis point more, so instead of 1%, if I get 1.01%, I'm happy. And so in doing so, all these people are going to keep demanding the foreign currency. The foreign currency is going to appreciate. US dollar is going to depreciate. By the time you bring your money back, your net return is just lower. Or let me rephrase that. Your net return is the exact same as what you would have earned had you put your money in Bank of America. Okay? I know this is a little bit confusing, but if you want to re-listen to this part that we just explained, it'll start making sense. By definition, that's the interest rate parity condition. You can't just invest in a country because it has higher interest rates, because interest rate parity condition says when you bring your money back home, you would have earned the exact same money as if you invested in the US or whatever your home country is. Okay? So we've done a mathematical example. How about doing How about solving the problem um, uh, without using numbers, right? So once again, let's start out by, and this applies to every, no matter how much money you have. Let's start out by saying you had 100 units of one currency, and the interest rate is I plus H, right? At home, so that's your two option number one is interest rate is I plus H in country number one. Interest rate is, so you take the 100 units of one currency, exchange it into a foreign currency, invest it into the foreign country for I to the power of F, and bring it back to the home country, right? So tomorrow, right? T plus one is tomorrow. Today plus one is tomorrow. Okay. Now let's see um, if we can prove the interest rate parity condition through sort of a quasi proof. Okay. So now to solve for let's take the log of both sides and see where we can get with it. So we take the log of both sides. Take the log of both sides, and you end up with 1 plus I to the power of H, log of the first side, equals ln, take big paren, this is simple algebra. You ask me what happened to the 100? Well, hundreds canceled, right? So you're left with this. Once again, we simplify this, and we end up with ln et plus ln I f multiplied by, so sorry, ln et multiplied by ln I plus 1 plus I to the power of f plus ln of 1 plus et. I know this looks hard, but it's going to get easy really fast. Okay, so all we're doing is simplification. So, and if you can see on the left hand side, we're just carrying this forward for multiple steps. Okay, carrying this forward for multiple steps. So what do you have here? You have, if you just keep this on one side and bring ET on the other side, you're going to see that you end up with, so let me redo this part, sorry. So through basic math, we know that ln of 1 plus IH is the same as IH, okay? We also know that ln of 1 plus IF, because what we did on the left, is the same as IF. This is super simple so far, okay? But what we don't know is, what we also know is ln of ET multiplied by ln of 1 over ET plus 1 is the same as ln of ET over ln of ET plus 1, which in turn is the same as ET plus 1 ET plus 1 minus ET divided by ET. Okay, so let's bring all of this back home. You're left with IH equals IF, IH equals IF minus ET plus 1 minus ET divided by ET. Look here what we have. This is T plus 1 is today plus 1 is always tomorrow. So this is tomorrow. This is today. This is today. Also known as new minus old over old, which is the same as percentage change. Percentage change of what? Percentage change of exchange rate. right? So you could also say that interest rate parity condition says that the differences in two interest rates are explained by the future change or expected change in the exchange rate. Differences in two interest rates between two countries is explained by percentage change in the exchange rate between those countries from t as in today to t plus 1 as in tomorrow. Okay, so we just proved the interest rate parity condition with a proof. Interest rate parity condition with a proof. But the good news is you don't really need to know how to derive all of this uh, with the proof. You just need to know what the interest rate parity condition is and uh, how the example works out. Okay? So let's do another example. Another example is if interest rate at home is 2% and interest rate at foreign is 5%, and the trader wants to invest 1,000 euros in the US. Well, that's the second option. Of course, the first option is invest 1,000 euros for 2% at home. Invest 1,000 euros is the second in the US at 5% is the second option, and the exchange rate is 1.326. What does that mean? That means if you invest 1,000 euros in the US, you'll have to first convert it into US dollars at 1.326 per euro. So you'll essentially get, for 1,000 euros, you'll get 1,326 US dollars to invest, okay, today. If you believe in interest rate parity condition, the question is, what do you think is going to be the future exchange rate, right? If you believe in the interest rate parity condition, the question is, what do you think is the future interest rate? Well, here's a trick. The trick is you don't even need to know any math, because the proof we did here tells us, let's plug and chug. 2% equals 5% minus percentage change in the exchange rate, which the only way this condition is met is if you have a 3% here. So what is this? So the answer to the question, without doing any math, as you can see, all of this is irrelevant, because the answer to the question is percentage change in exchange rate has to be 3%, and percentage change in interest rate has to be 3%, because that's the only way this condition holds true, where 2% equals to 5% minus 3%. That's the only way this condition holds true. How do we make sense out of this 3%? You see this minus sign here? It means that the exchange rate has to depreciate, right? So exchange rate between euro and dollar will depreciate by 3%. Exchange rate between euro and US dollar will depreciate by 3% per the interest rate parity condition at t plus 1, which is tomorrow, per interest rate parity condition. Let's dig a little deeper, right? So how did we get to this percentage change? Well, percentage change of the exchange rate was the same as ET plus 1 minus ET divided by ET, new minus old over old, right? So we know, and of course there's a leading negative sign outside the parentheses up here, right? Leading negative sign outside the parentheses up here. We know that because there's a negative sign here, which essentially means it depreciates, ET plus 1 minus ET has to be positive. Why? Because if it was negative, then negative, if if this was negative, then this negative with this negative would add up to a positive, and then you would have 5% plus 3%, which would get you to 8%. Interest rate parity condition does not hold. Okay? Interest rate parity condition does not hold. So let me get this out. Okay, ET plus 1 minus ET has to be positive. What does that mean? What does ET plus 1, which is tomorrow's exchange rate, minus ET, which is today's exchange rate, has to be positive? Well, it means ET plus 1 has to be greater than ET by definition. That's the only way ET plus 1 minus ET is going to be positive. So if ET plus 1, which means the exchange rate is going to be greater than ET, we know ET was 1.326. We know mathematically that this ET plus 1 number has to be greater than 1.36. By how much? By 3%. So let's do the math. That's the only way this condition is met, right? So let's do the math. I'm going to use a calculator. So the answer I get, 1.326 multiplied by 1.03 is 1.366 approximately. So the exchange rate for the interest rate parity condition is going to be 1.366 tomorrow. Because if you believe in the interest rate parity condition, only at this exchange rate, at the exchange rate of 1.366, can you get interest rate or return of 2% irrespective of where you invest, be it at home or be it at a foreign country. That's the interest rate parity condition. Okay. So in summary, interest rate parity condition says that IH, which is the interest rate at home, is tied to IF, which is the interest rate in the foreign country, is tied to IF and what? And market expectations of future interest rates, right? Or future exchange rates. What does this mean? It means that if I were to come up to you with an offer and say you can invest at home for 2%, invest at home for 2%, or invest at foreign for 5%, and the exchange rate today is 1.326, what you would tell me, well, is that in the future you expect the exchange rate to be 1.366. You expect the future exchange rate today to be 1.366. That's what this statement is saying. Statement interest rate parity condition says that interest rate at home today is tied to interest rate in foreign today and the market expectation of future exchange rate, right? So nobody has seen the future, but you have an expectation of where the exchange rates are going, or you can make an expectation of where the exchange rates are going based on the differences in interest rates. Okay. Now here's the kicker. This conclusion challenges the view that central banks can decide interest rate and that the financial markets will find an equilibrium. So let's think about this, right? The view that what we have just learned is essentially your future guesstimation of the exchange rate is how home interest rate and foreign interest rate is tied with one another. Could you then say that the future expectation of exchange rate is what really makes a determination of what the prevailing interest rates should be? Could you then say that interest rates are really determined by your and the market's expectations of future exchange rate? And if that is true, then what role does central banks really have in determining the interest rates? Right? What role does central banks really have in determining the exchange rates? So that's some food for thought. In the meanwhile, let's move on to section 13.3, the impossible trinity principle. Keep in mind here that this topic is relatively important because I think there's an entire chapter dedicated just to the impossible trinity um, principle. Um, so, so we're gonna address this in detail right now. So consider two exchange rate regimes. Of course, fixed and floating. Okay, fixed and floating. So what are the differences? Fixed is where central bank commits to upholding the exchange rate. Floating is where central bank makes no such commitment. Okay. So let's draw a chart that we drew a few minutes ago. Is the IS-MP curve. IS MP. This is I. Oops. This is I. This is 0, and this is output. Okay, IS-MP curve. But I'm going to draw a third line here, and we're going to call it the interstate parity condition, or IRP curve. Okay. Okay, and of course we know interstate parity condition says interest rates are a function of depreciation in exchange rates. Okay, interest rates are a function of depreciation in exchange rates. So just summary, IS curve is the investment supply curve. We discussed this already in the first section, so I'm not going to dig deeper into this. Do this. MP curve represents monetary policy and therefore central bank preferences. Okay, and central bank preferences. So of course the IS curve slows downwards because as the interest rates increases, output decreases. Monetary policy curve is an interesting curve in that it's a counter-cyclical curve. When the output is decreasing, interest rates should go down as well, and when the output is increasing, interest rates should go up, right? It's a counter-cyclical curve by definition. The third curve is something that you may have never seen, so we'll talk about it for a second before. The IRP curve represents interest rate parity condition, which we just discussed a few minutes ago, and it says that the interest rates across the globe must be the same. IRP curve is the interest rate parity condition that says interest rates must be the same across the world. Okay, so that's the setup to this picture that you're seeing. So in this case, general equilibrium requires that goods and financial markets must be in equilibrium. Goods market is of course IS curve. Financial markets is of course at IRP curve. At the intersection of IS and IRP. Remember, monetary policy curve is exogenous. It essentially identifies central bank preferences. So there's no, when you think about the concept of equilibrium, really the MP curve changes or you move up and down along the MP curve to bring an economy back to the equilibrium, right? Not the other way around. Whereas the IS and the IRP curve is what determines the equilibrium. Okay, so cause and effect issue here. Okay, so our MP curve is a little bit unusual in that you think of it as exogenous. However, so we know general equilibrium requires IS and IRP curve to converge, but there's three lines. And with three lines, you get way too many possibilities. What are those possibilities? Well, they're points A, points B, and point C. Three lines result in too many possibilities represented by points A, B, and C. Okay. So what are points A, B, and C? Or what are essentially the three options that you have, right? So graphically, the impossible trinity, the three options, principle says that you can have only two options are compatible with one another. What are those three options? Option number one, full capital mobility. Here, you're essentially allowing outside parties or foreigners to invest in your country. Fixed exchange rate. So here you're exerting control over exchange rate. And number three is autonomous monetary policy. What does that mean? Essentially, you're trying to exert control um, over monetary policy or interest rates. Okay, so let's consider a case of fixed exchange rate regime. That sits at point A, where goods market is in equilibrium. Okay, it sits at point A. Point A is right here. The goods market is at equilibrium, and central bank makes independent monetary policy, and central bank has autonomy, right? So this country has two things going for it, right? The goods market is in equilibrium, and there's autonomous monetary policy. But there's a problem. Remember, in equilibrium, both goods and financial markets have to be in unison, have to be in equilibrium. So in this country, point A, point A is about the IRP line. What does that mean? Well, what that means is if you move along point A to the y-axis, you'll see that the interest rate is higher than the prescribed interest rate by the interest rate parity condition. As a result, interest RP line and interest rate is greater than, let me do this. Prevailing interest rate at point A is greater than I star plus depreciation, which is the equilibrium interest rate for the interest rate parity condition, right? This attracts foreign investments, which causes currency to appreciate, But currency cannot really appreciate in this economy because this is a fixed exchange rate regime, as we see here. So you cannot let the currency to appreciate in this economy. So what options does the central bank in this economy have, since it is committed to maintaining fixed exchange rates, right? So the central bank has no choice but to respond by, how does it respond? So it can, first of all, what has happened is foreigners are demanding its currency and flooding the market with foreign currency and taking the home country's currency from the foreign markets. So the central bank in the home country has to do the exact opposite, buy up the foreign reserves and flood the markets with its own currency. So the central bank has no choice but to respond by selling its currency and buying up reserves of foreign currency. Well, the problem with this effort is that it does not really address the problem at hand. What's the problem at hand? The problem at hand is the interest rate in this economy is greater than the interest rate parity condition. So the central bank would have to keep doing this for eternity and beyond, uh, um, but it can't afford to do that. Eventually, it'll give up. So either the central bank does this forever, or it gives up, because the central bank response is not really addressing the higher interest rate. Right? The central bank response, we know, is not really addressing the higher interest rates. Oops. So central bank policy is not really addressing the higher interest rate problem. So either way, this example shows that the central bank loses monetary policy autonomy, right? Either way, the central bank in this country uh, loses monetary policy because it's unable to choose the interest rate. Now think about it, right? If it were able to choose, so when we say it's unable to choose interest rate, what are we really saying? What we're saying is that it's unable to choose an interest rate that is different than the interest rate parity condition. Because if it chooses the interest rate that is at the interest rate parity condition, is it really choosing an interest rate? It's not. All it's doing is uh, it's agreeing with the interest rate parity condition and setting its interest rate at that point. So really, the central bank, in trying to control the interest rate, it's setting an interest rate that's different from the interest rate parity condition. And what this example shows is that's not possible, right? It loses control over the interest rate parity condition. So the IRP line must be respected. And the central bank central bank preferences represented by the MP curve become irrelevant. Okay, central bank preferences represented by the MP curve become irrelevant. Now let's talk about a second example. Okay, so now consider a case just like the one above, but the exchange rate is allowed to float. Okay, so it's the same case as above. The exchange rate is allowed to float, and this economy also starts at A, right? It also starts at A, where goods market is in equilibrium because we are on the IS curve. Well, actually more than V, it's really point A. A is on the IS curve. And central bank acts independently. Once again, because A is on the MP curve. Let me change this is to this R to an is. Okay. We know in point A, exchange rate appreciates. We already know that. Except this time around, the central bank no longer opposes. Well, so that must be the end of story, right? If the central bank no longer opposes, it's on point A, what's the problem? Well, the problem is the central bank still has a dual mandate. The dual mandate is to lower or to have maximum employment and price stability. But when, as we explained in the prior example, when exchange rate appreciates, what happens to imports and exports? When exchange rate appreciates, foreign goods become cheaper, so imports increases. So imports and home goods for foreigners become more expensive. So exports, we know that y equals c plus I plus g plus x minus m. If imports were to decrease, or imports were to increase and exports were to decrease, then output would go down. So even if the central bank doesn't care about the appreciating exchange rate, because this is a floating interest rate, floating exchange rate economy, it still has to respond to the impact of the appreciation on the output. And it responds by, or, as a result of the decrease in output, IS curve shifts inwards. IS curve shifts inwards until it passes through B, where international financial equilibrium is achieved, right? And central bank is pursuing its chosen monetary policy, which is what? Which is to lower interest rate to IRP level of I star plus depreciation. So in this case, central bank gets to stay on the MP schedule or curve, and the IRP condition is satisfied, right? So let's look at the diagram again that we drew a few minutes ago and look at what has happened, right? So we're at point A in the second example, and the exchange interest rate is greater than the IRP condition interest rate. Therefore, the currency appreciates. But this time around, the central bank does not care. The central bank does not care, but because of the appreciation in exchange rates, foreign goods become cheaper and home goods become more expensive, right? So imports increase, exports decrease. As a result, the IS curve shifts and it keeps on shifting until it hits point B. At that point, the central bank reduces the interest rate from where it was to the IRP level interest rate. So in this instance, it gets to satisfy the IRP condition. Okay. So these are the two differing examples of what happens when an economy is a fixed exchange rate regime that also tries to control the interest rates. And in the second case, an economy is a floating exchange rate regime that tries to control the interest rates. Okay, so now that we have a good understanding of impossible trinity principle, let's draw it all out, right? So I'm going to draw a diagram. It's called the impossible trinity principle diagram. Okay, so scroll up a little, draw a triangle. Oops. Draw a triangle like this. And we'll clean it up a little bit. So here's the triangle that has three sides. The top side is fixed exchange rate. One of the other areas is full capital mobility. And of course, the third leftover point of the triangle is autonomous monetary policy. So what do each side represent, right? So each side, on this side, for example, you get to have a fixed exchange rate and autonomous monetary policy, but you lose control over capital mobility, right? So you cannot control capital mobility. This side of the triangle is something that we did not discuss. We just had two examples because they represented this. They represented this side and this side. We did not talk about this side, partially because there are very few countries left that do not allow for full capital mobility, right? Like one of the countries is North Korea, right? So let's say what do you get on this side? You get fixed exchange rate, so you control exchange rate, and you get autonomous monetary policy. Let me clean this up a little bit and also clean the errors up to make them stand out. Okay, so you get these two things. Here you get full capital mobility and autonomous monetary policy, but you don't get to control the exchange rate. So it's floating exchange rate. So full capital mobility, autonomous monetary policy, but floating. Of course, then floating exchange rate essentially implies you can't control exchange rates. And then here you get, by now this must make sense. Here you get fixed exchange rate and you get fixed exchange rate and full capital mobility. but no autonomous monetary policy. So these are the two um, things we talked about. This was in green ink. We spoke about this in green. So I'm going to draw the screen. And this was black example above. Okay. All right. So now let's talk about examples of who does what. So this is section 13.3.3. Who does what? Okay. Who does what? So we'll say so I'm gonna write this in green pen because it corresponds to green area or green example. Full capital mobility and autonomous monetary policy and floating exchange rate. Who does this? So this is pretty much all the, well, the hardcore capitalist democratic society, right? So this would be US, Japan, UK, Switzerland, and Sweden, right? Who does the black piece, which is full capital mobility and fixed exchange rate and no monetary policy, right? So no control over monetary policy is what we mean. This would be, in some ways, the Bretton Woods system. Bretton Woods system that formed in 1944. I talked about this in chapter 1, the Bretton Woods system. And of course, it collapsed very fast. The second group of people that do this is the European Union, the area that's at the heart of our course. European Union is an example of this. And then the third example I will write in purple is fixed exchange rate, monetary policy autonomy, and capital controls. So a lot of our international students may be able to associate with this. China is a big example of this. So a funny story about China, it is my understanding that they can't necessarily buy too much foreign currency to invest in foreign markets. Yet, if you read newspaper articles about housing market in Canada, in the recent past, I would say in the last since the financial crisis, essentially, majority of the homes or a good portion of the homes in Toronto, for example, are bought by Chinese immigrants. So the question is, how are they able to buy these in fact, so many houses and condos and townhouses are bought by Chinese immigrants that locals can no longer afford it. And in the recent past, the Toronto government had to pass a law that charged taxes for foreign purchase of real estate. So, for example, if you're not a Canadian if you were a Canadian and you bought a house, you won't be imposed a tax. But if you're a foreigner and you bought a house, you'd be imposed a tax. So Anyway, the question is, if China has capital controls, how do Chinese people buy homes in Toronto? It is my understanding, one of my students told me in one of the prior classes, is that they all get together, and I think the limit is $50,000. Everybody and their relatives essentially contribute $50,000 each, and then they're able to buy a condo, say for $300,000, $400,000. Then the following year, once again, everybody contributes $50,000 for someone else's purchase of a home, and they do that until everybody in the sort of group has successfully bought a condo in in Canada. So that's how they go about um, buying all these properties in Canada. So China is an example of fixed exchange rate, monetary policy autonomy, and capital controls. Okay. Uh, of course, a quick summary. Capital controls Capital controls and interest rate parity condition are inoperable. You cannot have both. Okay, so that was a quick section 13.3.3, section 13.4, monetary neutrality. So what is the monetary neutrality principle? We saw that central banks decides on the desired interest rate it wants in the market or in the country that it regulates, it wants to see prevailing. How does it do that? By making money, which is the same as cash, more or less abundant. Here where it starts getting interesting. However, the impact of central bank and monetary policy is only visible for 1 to 3 years. It's only visible for 1 to 3 years because beyond this time horizon, monetary policy loses its effectiveness. And so when I say it loses its effectiveness, what does it mean? It essentially loses its ability to influence demand. Okay, it loses its ability to influence demand. And that's, if you think about it, that's the name of the game, right? The whole point in lowering or increasing interest rate is to allow consumers like you and I to make buying decisions. As I mentioned before, interest rates go down. They go, well, what they are right now, they go to all the way to 0%. Refinance for homes, refinancing applications for homes go through the roof, or people want to buy more homes, bigger homes, right? Because given that my income is constant, the only way I'm able to buy a bigger home and the more expensive home in a better area is if interest rates are low, right? Given my income is constant, the only way I can buy a bigger, better home is if interest rates go lower. So the name of the game, monetary policy game, is to influence demand. But after what we are arguing is that after 1 to 3 years, um, the central bank is not able to influence demand. So monetary neutrality principle says, in the long run, monetary policy loses its effectiveness because, why do you think monetary policy loses its effectiveness? Let's continue with the same example. Um, right now we're in 2020, in the middle of coronavirus crisis. Last week, the Federal Reserve lowered its interest rate from 1.5%, 1.25 to 1.5% to 0 to 0.25%. As a result, mortgage applications went through the roof. More people want to buy houses, right? What do you think is going to happen? And if interest rates remain at 0% for the next, say, 3 years or so, what do you think is going to happen within the next 3 years? Well, the sellers are going to get smart and they're going to realize that they can charge a higher price for the same house because people are getting pretty much free money from the banks in terms of ability to borrow, right? People are able to borrow um, for 30-year mortgages for as little as 3%, 3.5%, right? And so if I'm a seller, I recognize that people who could not buy a home in the past because the interest rates were higher are now able to afford a home. Therefore, if I were to increase my price, I'm sure that I would be able to get someone who's willing to pay a higher price because they're getting a lower interest rate. So, monetary neutrality principle says in the long run, monetary policy loses its effectiveness because the price level, as I mentioned before, increases in the same proportion as money stock. Price level increases in the same level as money stock. Okay. So we're here in the home stretch. Let's do section 13. Okay, so section 13.5 is called the real exchange rate and purchasing power parity principle. The real and purchasing power parity principle. Let's start with the first of the two topics, real exchange rate. Okay, so let's say price of goods in home currency, which, since we are studying about the European Union, is euro, is equal to P. Okay, so the price of goods in home currency is P, expressed in euros, P euros. Okay, so if you want to compare this price, to the price of foreign good, um, P star, and of course in foreign currency. So once again, we're comparing the price of the same good in two different countries. In foreign currency, it's P star. Say in dollars, P star is dollars, so P star dollars. Okay, so we'll say price of good in foreign currency, which is, as I mentioned before, dollars. We'll call it P star. Okay, and the exchange rate now which is dollars per euro is equal to E. So for example, let's say the price of goods in home currency is 100 euros. Price of good in, or the exchange rate is, you get $1.30 for each euro. That's the exchange rate. So then price of European goods in dollars is equal to EP, which is E multiplied by P, and you end up with $130, right? E multiplied by P is $130. So what has this allowed us to do? This has allowed us to converting the price of goods in euros into US dollars has allowed us to compare EP with P star. Remember, P star is the price of goods in US dollars. So thus, we can compare EP, which is price of European goods in terms of dollars, with price of the same good, price of American goods in dollars. Okay, why? Because they are both measured in dollars. They're both measured in dollars. Okay. Okay. So now let's make some observations about real exchange rate. So of course, real exchange rate is the relative price of domestic goods with respect to foreign goods. So if you notice the difference, the subtle difference between real exchange rate and nominal exchange rate is that we have taken out the currency component in this. We don't care what currency we're using. We're just saying what's the value of one good relative to the value of the same good while keeping um, the currency constant. What's the value of one good in one country relative to the value of the same good in another country while keeping the currency constant? Okay, so when real exchange rate appreciates, domestic goods become more expensive. And if you think about it, this is no different, become more expensive with respect to foreign goods. If you think about it, this is no different than nominal exchange rate. When nominal exchange rate appreciates, domestic good becomes more expensive, exports go down, imports increase because relative to foreign goods become cheaper. Relative to foreign countries' goods are now cheaper, so you'd import more. Okay. So now what causes real exchange rate to appreciate? Real exchange rate appreciates when, it's obvious, right? If you look at the formula of EP over P star, which is the formula for real exchange rate, it can appreciate if E appreciates. And what is E? E is the nominal exchange rate. Or, and this is the key, this is what differentiates real exchange rate from nominal exchange rate. Domestic price level, once again, we are in Europe, so domestic prices are P, rise faster than foreign prices, which in this case is American prices known as P star. Okay, so that's the concept of real exchange rate. So when real exchange rate appreciates, the country becomes less competitive. And if you think about it, this is nothing different from nominal exchange rates, because when nominal exchange rates appreciate, the country also becomes less competitive in the sense that its exports are more expensive. So foreigners are gonna demand more or less of its exports, whereas imports become less expensive, and home consumers demand more of imports. Okay, so let me just clean this up because this is not a sub point; it's a separate point. Okay, so that's the real exchange rate. Now let's talk about purchasing power parity principle, where we'll actually make an application of the concept of real exchange rate. So purchasing so purchasing power parity principle. What is the purchasing power parity principle? So PPP asserts that the rate of change in nominal exchange rate, the rate of change in nominal exchange rate between two countries can be explained by the differences in the inflation rate between these two countries, which in other words is also known as inflation differential. Okay, so PPP asserts that the change, or you could even say percentage change in nominal exchange rates between two countries can be explained by differences between inflation at home and inflation at foreign. So pi h and pi f, aka inflation differential. Okay, so we could say percentage change in exchange rate is equal to pi f minus pi h, which is called inflation differential. Okay, this is called inflation differential. So in simpler terms, if inflation at home is higher than inflation at foreign, what does that mean? Inflation at home is higher than inflation at foreign. Our currency should appreciate, right? Our currency should appreciate. Conversely, a country with higher inflation sees its exchange rate depreciate, right? With higher uh, higher inflation sees its currency depreciate. So I made a slight error. What I meant to say is inflation at home is lower than inflation in foreign, then our currency should appreciate. And essentially, the key takeaway is that a country with higher inflation sees its currency depreciate. So let's see if we could actually prove that. Let's see if we could um, prove that a country with the higher inflation should see its currency depreciate. Okay, so I'm going to use a textbook example, which is in table 13.1. And here what they do is they compare purchasing power parity between Italians and Germans right before they joined the European Union. Purchasing power parity, Italy and Germany from 1960 to 1998. 1960 to 1998. So I take that back. This is not the 1960 to, of course, 1998 is not the period of joining the European Union. It's a period, 1998 is a period at which they adopted the euro, right? Of course, Germans and the Italians were the founding members of European Union, as we learned in chapter 1. Okay, so the average annual inflation rate for Italy between this period of 1960 to 1998 was 8%. Average annual inflation in Germany in the same period was 3.2%. So what does our model tell us? What does our model from here tell us? Well, it tells us that since inflation in Germany is lower than inflation in Italy, um, Italian lira should depreciate by the difference, right? By the difference is 4.8%. Italian lira should depreciate by 4.8% each year because this is the average annual inflation between Italy and Germany. But what was the reality? The reality was annual depreciation, average annual depreciation of lira was actually 5.3%, which of course, what we know is it's very close to 4.8%, but it's not precisely 4.8%, it's 5.3%. So why could that be the case, right? The question is, if we believe that the change in a percentage change in exchange rate is explained by differences in inflation rate, why is the case that Italy actually experienced a worse depreciation than 4.8% that we expect for our model? And the answer to that is pretty simple, right? The answer to that is pretty simple. Could it be that the real depreciation of lira is further, oops, is further exacerbated. It's further exacerbated by an even worse relationship with another country, by an even greater inflation differential with respect to another trading partner. In other words, Let's say Italy traded a lot more with um, France than it did with Germany. Let's say it only did, 25% of trade, uh, 25% trade with Germany and 75% trade with France. And in addition to what we know here, which is that the average annual inflation rate in Germany was just 3%, what if we were to say average annual inflation in France was even lower at, so say 2% approximately, right? Approximately 2%. Would you then say that the cumulative effect, therefore, cumulative effect is a depreciation rate of 5.3%, right? Because Italy doesn't just have a trading relationship with Germany, it also trades, in this example, with France. So approximately, this explains why Italian depreciation rate was 5.3%. But the key takeaway here is that PPP, um, an important implication of purchasing power parity is that real exchange rates, EP over P star, is constant, right? Why is it constant? Because the example showed that if the um, uh, that any changes to the exchange rate, can be explained away by the differences in the price levels, as we saw um, in the example with Germany, France, and Italy, right? As we saw in the example from Germany, France, and Italy, where both France and Germany had significantly lower inflation rates compared to Italy. And as a result, Italian currency had to depreciate, in this case, by 5.3%, right? So that's the sort of basic nuts and bolts about the real exchange rate and the purchasing power parity principle. But as I mentioned, this is just an introduction to macroeconomic concepts that we'll be using in the chapters that follow. So I'm sure we will address these two concepts in a lot more detail in chapters that follow. Okay, so that's the end of chapter 13.